Hello everyone, hope everyone can hear me okay. We are in my new setup we've got going on here. Hopefully this is working okay, but I've finally sorted out my office space. It's been, oh man, that's way too loud for you guys. Way down. Back in track, there you go, that'll do. How is everyone? Hope you're doing okay. But yeah, welcome to the brand new setup for my new office space. I'm no longer stuck in the kitchen like a dining table. Actually, I now have a dedicated space, dedicated setup. So hopefully everything is working okay. Let me know in chat if anything is going wrong. Apologies for having to cancel the previous streams last weekend. Very tired, very exhausted, mentally, physically, and all above. And this past Wednesday, I was setting up this place. So yeah. We're looking good. As you can see, you've got some loads more space. I've got a desk now. I've got an actual chair. I'm no longer in pain. Hallelujah. So hopefully you can get more stuff out, be more productive in this space. I'll do a video tour of what I've got in here and what I've been purchasing. Still a bit of crap here to get rid of, and but by and large, it's looking quite good. Anyway. So, what are we doing today? So today is Retro Remake, and Retro Remake is a chance for me to go back in time and try and do a modern retelling, a remake of an old retro game. This year, we are tackling Legend of Zelda Link to the Past, or a Legend of Zelda top-down type game anyway. So what we're doing is we're trying to remake that with modern sensibilities in Unreal Engine 4. This is episode 3. If you want to watch the previous 2 episodes, they are available on archive, and this one will be 2 in a few weeks' time for YouTubers, but immediately for Patreons. And for Patreons, you get access to all of the project files as well after each episode as well, so you can play along and make stuff too. Hello everyone in chat. We do have chat open on the side here, so hello Perfect Tease, hello UE5 Project Storm, hello Angus, hello everyone there. Hopefully everyone's doing okay, everyone's staying safe and looking good. Yeah, brilliant, excellent. So, before we jump into the actual Unreal here, there are still a few slots available for private sessions in the month of April. So if you want to get hire me for some session time, or hire me to do some work on your projects, there's some time available there remaining. Not much, time, but there is still some time available there. So if you want that, you can email me at support@ryanlay.com for more information. Prices and everything else is on the website, ryanlay.com. Okay, I think we should jump in, don't you? Okay, so we're going to jump in and into the screen here. If this all works perfectly fine and without any hitches. There we are. Let's just move this up a little bit. I'll get some backing music for you guys. Yeah, there we go. Not too bad. Yeah, a UEFI project. I've done some work for people. Just finished doing like a interactive door system for someone last week. If you want, all prices are different per thing, so just let me know. Anywho, let's get started. So where we left off last time was we started doing some combat stuff. Which play here. We got a hero in the map here, and I can swing my sword and just attack things. Okay, very basic stuff. Nothing too flashy just yet. What I think I want to start doing on today is tackling the key concept of Zelda-like dungeons is the puzzle element. So you're pushing the switch, hitting a button, opening doors, moving other things, pushing blocks. I want to start tackling that stuff live here tonight. So hopefully we'll go through this. Hopefully get through this in tonight's episode. This is all live, so you'll see me bug fixing. You see me trying to figure stuff out live. I haven't really done too much prep for this at all, really. To give you an honest look at what I do and the way I work. Okay, so let's get started. So as I said, I want to work on getting my interactive element done so that when I push a switch, it opens a door or does something else. Now, something like this you could be done in like level blueprints, for example, but I'm thinking of developing a single actor type system that can handle locks and keys, essentially. So you do this, this happens, sort of attitude. So let's think about how we could possibly do this. Right, so let's first of all, I'm going to get rid of these things, first of all. Okay. And instead we're going to put in a sort of a fake button type thing. So let's make a switch. Okay. Make a switch. And we'll call this, we'll call it floor switch. And this floor switch is pretty basic. I'll just do a simple cylinder. Like that. And what we'll do is we'll have a collision on it. A sphere collision. And we'll scale up the radius of this to cover the button. So the idea is that when the player walks over this, it triggers. And I only want the player to affect it. I don't want enemies accidentally to trip over it and let the player through if they need to be. So on this sphere here, we're going to go to the event graph and we're going to right click on our collision component here and go add event and choose begin overlap. So on the begin overlap, we've got this other actor pin. We're going to drag this out and do a check to see if it's equal to the player character. Now I don't need to do a cast here because I don't need access to anything the player has. I just need to check that it matches what the player character is. So we're going to drag that out and use get player character. And we'll put that into a branch. Well, probably it's late. Okay, so in that branch, if it's true, it means the player walked on it. So in here, I'm going to make an event dispatcher. And we're making an event dispatcher for button, no, switch pressed, we call it. Switch pressed. Okay. And we'll bring that out and choose call. Now, the benefit of using an event dispatcher in this case is that I can tie things to this indirectly, and this thing will shout out to anything that's told to listen to it. So multiple things can be triggered by this thing, and without it having to know exactly who needs to know when it's been pushed. Alongside that, we'll make another custom event in here. We'll call it button We call it switch. Switch. Can't do switch press, can I? No. Switch on. We'll switch on. And we'll call switch on this as well. Now, immediately I'm not going to use these. These are going to remain quite blank, I think, for now. But they're useful to have because they are events that are happening. And you kind of want to make sure you've got events that are things that could happen in the game. So when I push the button, that event should be a thing that we could tie some code onto. So I've got switch on and we do switch off. There's two events. So switch on is going to be called when we walk over it, and what we do is when we walk off of it, and we do binding again on the sphere here, add event, end overlap. And once again, we will make sure we are calling equals to get player character. And put that into a branch, exactly the same. Okay, and in here, we're going to have another event dispatcher and do switch released. And we'll call that one out as well. Then we're going to call the switch off. Then. Wow, thank you, Simplify. It's amazing. And Riley, thank you. Alright, is that correct? I don't know, Riley, if that's recent or not. Are these late? Early? I can't tell. In either case, thank you. If it is, if it is now. Okay, so we've got switch on, switch off going on here. And that'll do. We could animate this as well and do stuff like if I want to make it move down when I walk on it, which I could do, I guess. So when I do switch on, I can take the cylinder out here and we can say move component 2 and rotate to move, and cylinder move will be its current location, get location, and we're going to change it into Z. So we're going to add vector, plug it in there, and I'll move it down 10, no, minus 10, sorry, because we're going down over 0.2 seconds, 0.5 we'll go for. Then I'll do exactly the same thing here. We'll switch off. But this one we want to plus 10. Okay. So if I drag this into the world, put that there. I don't know if we'll see it moving, but it will. Oh, what's going on there? Oh, no, plus, yeah, what? Hit world location, switch. Oh, not world location, I want to get relative location. Whoops. Get relative location. So, because this is a child of the root, we want the relative location, not the world location. Get relative location. Hi, X Draco. Okay. You can tell it's going down, it's just so subtle you're not going to notice it. But never mind, it's there. Okay, we can... and I want to make it equal to 0, I think, here. No, switch out, no, switch off would be 0. No, okay. It's going to be plus 10. Yeah, there you go. Okay, so we've got a switch. Change the colour of the switch and the click sound. Yeah, we can do. We'll do that in a moment. Once we get tied up working with stuffing. So I want to make it do events inside the game. Okay, so we've got doors here at the moment, and these dungeon doors currently have no locking. They're just open all the time. So if you haven't seen this before, when you walk up to a door, they're open, and it'll push the player through automatically, and then close behind them. So obviously sometimes the door will be shut and locked. So we need to make it so we have to get a key or unlock with a switch or whatever. So we need to edit our doors here to allow that option. So let's go to edit door code, and we'll make a new variable in here. And we'll say requires key. And we'll have locked boolean as well. Okay, so when we get near them, we've got begin overlap here. We only want to do open door and player character here if the requires key and locked is both false. So here we'll get requires key and put this in a branch, and that goes into there. And say both of these need to be false in order to get there. So do not, and then put an and in. Now both of these will be editable because I need to change it in my level. So this will only do it when these are both false. Okay. So if I went up to this door here, I go turn on requires key or unlocked, hit play, and I should no longer be able to go through it. Okay. Even if I turn one of them off, so let's say this one requires key and this one is locked, it should still remain closed when I go near it. Like that. Okay. So what we're going to do is going to make it so that when we hit this switch, that door's going to open. So we need to find out a way to tell that door to listen out to that particular switch. Now, we're going to have multiple doors inside our game. We don't want to be coding each one individually. And they may not be tied to individual switches. They could be tied to a combat situation, or could be tied to, I don't know, whatever. Okay, there's loads of things that could happen with that. So what we're going to do here is we're going to make a sort of a lock actor, that sort of parent. And there's loads of ways of doing this. You don't have to do it like this way, but I want to do something a bit different that I've not done in the past. And I'm like a separate actor which controls what is the condition to open things up. So make a new actor here, and we call this one event condition. And the event condition is going to have by default two things. It's going to have a lock and a key. So we're going to go into the variables here. We'll go into or cause and effect basically. So we'll do cause, and the cause will be an actor type. Actually, no. What do I want to do? What do I want to do? No, what I want to do, not event condition, we'll delete that. And instead, so we've got a switch here. This is like a physical representation of a switch, but I'm also going to have that abstract version of it. And we'll call this one switch. And this thing has no mesh, it has nothing like that. It's just there to control the flow of a direction in the game, okay? So, yeah. In here, we're going to go to variables here. And we're going to make a variable to tie it to an event inside the game, okay? So in here, or the result of it, sorry. So we'll go into resulting. No, what do we call it? How do I do this? Hang on, let me think. Let me think how we do this. Because the main thing is I don't want doors to be only working with switches. They need to work with, like, say, combat scenario. So if you beat all the enemies in the level blueprint will then tell it to open. We can get the door to handle that. Or I guess we could just do it with a level blueprint. There's no point doing it here. After all, that is what a level blueprint's for. So we'll just do a level blueprint. So when I design my level, I could say, okay, this switch needs to be pushed to open this door. So I'm going to go to my level blueprint. And this is what the level blueprint's for. The level blueprint is to handle like flow like this, where it says event. So when this happens, then do this, based on that particular level. And each dungeon is going to be very different, have unique things. So it's good. So I've got this switch here. We're going to level blueprint. And we'll go and create a event for the floor. I just realised I spelled floor wrong. So we've got these event dispatches that are made appear here. So on the add switch pressed, we've got this one. And this refers to that event dispatcher I made. So when the switch is pressed here, I'm going to get this door reference. And create reference to door. And we're going to tell door, no, we'll take it to be locked. Oh, sorry, set locked. And we want to set locked to false, leave it like that. So when I walk over it, that door is now going to be open. Yay. That's it. Cool. And that could be tied to many things as well. So let's pull in my pot idea, okay? So here I've got pots. And let's say I've got to destroy all the pots. Imagine these are like enemies, basically. So we've got these things here. And we'll say I have to destroy both of them to unlock this door, okay? So we're going to go to my level blueprint and see how we work this out. So we've got references to pots here. We're going to go add event collision. No, undestroyed. So it's when it's destroyed. We want to make a list here of the pots that we want to do. So pot lock, we'll call it, and that'll be a list of pot object references as an array. And no, what would be the best way of doing this? If I wanted both pots to be destroyed to open a door. So on destroyed. Right. On begin play then we need to tell it what the lock requires, what pots needs. So with each pot selected, we'll go to level blueprint, drag this out to get and add unique, and create a reference to pot 2. And add unique again. Choose this one. Reference to pot 1. So it's set up on the begin play, and then when that's destroyed, we take the pot lock and we remove item. That should be okay going in there. Okay, cast to it then. Cast to pot. Okay, now we move it from that list there. And also I'm going to do this destroyed for the other one as well. So I've got the other one selected. Go on here. Add undestroyed. Can I connect these both up to it? Nah, it works. Okay, never mind. We'll just do it. A copy. Okay, so once both of these are removed, we need to check what this pot lock actually is, if it's empty or not. So at the end of these, we're going to go and do a pot lock and go is length. If it's less than or equal to 0, and put that into a branch. I'm not going to make this connected up yet, but we'll take the pot, get the length less than or equal to 0. Then I want to take the door. Where's it? Door. Copy that. True. There. Okay, now the reason why I'm not connecting it up because I want to use it both times. I can just make this a function. Pot lock func. Put in the top one and put in the bottom one. That's it. So in here, does that, that does that, that does that. Cool. Okay. So if I hit play now, if I hit both of these, destroy them. Yay! It works. Okay. So now we've got a way to handle what happens when we open the door via switch and when we destroy things. And those things could be enemies as well, it's not just pots. So we can make a battle sort of scenario. We can also make a scenario where we walk into a level and it locks the whole level down and so forth. Or check if a cube that we're pushing is in the right place. Okay. Next, I think we should try doing block pushing, I think. So the classic get behind the block, push it along, and you can only push it in the 4 directions. And when it gets to the designated place, it will unlock the door. That's what we're going to try and do. So first of all, we need a block that we can push. So class, actor, and we'll call this one pushable block. Now, pushable blocks are notorious for being a pain in the ass to sort out, so hopefully we can solve this. So we're putting a cube in here. Let's see what it looks like size-wise. Yeah, okay. Do that. Let's just make sure it's not on halfway through the floor. So we're going to move this up a little bit. Cool. Okay, right, so to push this, there's a couple of rules we need to decipher. And when you ever come across these problems, we need to think of the rules first before you go into the coding of it, because you can get lost. So the rules are, it will start pushing when the player is up against it only. And the player has hit no buttons, they just push forwards on their stick and it'll push it forwards. Next, once you move in a direction, you can't then change direction or steer it. You have to be able to go to the other side of it and push it that side too. You only push. Okay. We won't worry about pulling. We'll just worry about pushing. So, there's 2 ways of doing this. You could do a physics object, which probably may be the easiest way of doing it, and then constraining it to an axis. So we could do that. Otherwise, you have to process it maybe, but I think we'll do a physics option. So on here, we're going to pushable block, and I'll make this cube the root. So whenever you make a physics-based object, make the thing that you want to be movable the root. Then I'll go simulate physics, and we'll turn it on by default for now, but we will turn it off and on. And then in here, you've got constraints, and we can lock the position in X, Y, and Z. Now, we need to tell it which way you want to constrain it based on where the player is in relation to this. So if it is behind it, then we're going in the X coordinate, okay? Because X is forwards in this case. Okay, so X is that way. Okay, so if we said if the player is in front of it or in front of it or behind it, we're going to lock all the others except for the X coordinate. So what I'm going to do actually is if I put in a box collision around this thing, that'll make it a bit easier to control. We'll do 110, I guess. Oh, yeah. We don't even need to have to do it the Z that much. We can do like just 20. Be fine. Okay. Constraints, yeah, that forward and right vector dot product. Yeah, you could do it like that. Yep, that's why I'm doing it. So we take, I explain how, well, whilst we're here, we'll explain dot product and how it works. So let's do the overlap for this. Okay, so let's do add begin overlap. And for this, on overlapped actor, we want to check first of all if it's equal to the player character. First of all, you then want to get the other actor and get their forward vector. So their forward vector is important because we need to know what direction they're facing in relation to this. So if we get the forward vector of the player and get the forward vector of this as well, you can do a dot product of these two. So what is a dot product? A dot product is, without going into the mathematics of how you calculate it, essentially it in this particular case will check how alike two vectors are, how close they are together, essentially. So I'm doing a print string here and I'll show you what I mean. So okay, so that's going to look at, so this one is facing forwards, going up like so, same as the player is currently. So if I walk up to it behind it, I should make it bigger actually. You see it says 1. Now 1 refers to me and him facing the same direction. If I go this side, it becomes negative, well, it'll be close to -1 because it's moved a little bit, but -1. So if it's 1 or -1, it means that we're in the same sort of axes. If I go from the side, let's restart it so it's not flying about across the screen. If I go from the sides, you'll see it goes to 0 because it's not alike at all. It's completely at tangent of it, or perpendicular to it. So what we're going to do is use the absolute value coming from the forward vector to determine whether or not we're going forwards, or the 0 if it's equal to 0. Work out if lock it in the the left and right, and then the only directions we want to go up, down, left, and right. So on here, we're going to do the dot product here and get this out, and we'll do abs. Now absolute means it will just lop off the sign. So if it's -1, it becomes 1. That's all it does. Okay, so it gets the absolute value, and then we want to say if is let's say nearly equal. Yeah, nearly equal. Say if it's nearly equal to 1 with an error tolerance of 0.01. It shouldn't be either because we're going to lock it in a moment. So we'll do that. Put that into a branch. And in that case, then we want to drag out the cube and get the constraints mode. And we're going to constrain the, I think this is the right node. We'll find out. So if I want to constrain it in this one, it would be the YZ plane. So test that out. If I was to push it from behind it, it won't fly off to the side. It should just go forwards. Oh no, I'm constraining the wrong plane. Yep, wrong plane. Let's do that. So on the XZ plane. Oh no. I misread it. Sorry, my bad. It's not XZ. You just want you want it constrained to allow movement in the XZ plane is what we want. So it's where you want it to go. It's not where you're locking off. So that'll be fine. Play. Yeah. Stuff like that. Okay, so you got that. Next thing to do is turn off a load of other settings on the thing. Actually, let's put that one in as well. So if it's false, then there, drop in there, and change that to the YZ plane. Or I just do custom plane actually. No, not custom plane. Just do YZ, be fine. Then go to the box, the cube, sorry. Go to its physics components. We need to turn down all the various settings on it. So we want it just to slide nice and smoothly along. Don't want to get stuck on stuff, things like that. So we're going to turn down the angular dampening. We want to do that. Constrain will lock rotation as well in the X, Y, and Z, so it doesn't roll around. I'm crazy. Are you growing your beard out? Yeah, not on purpose, just through sheer lack of drive. And we have to then turn down the. We might have to turn down the dampening as well, but let's see how that looks with the rotation locked. Oh, wrong keys. You should not be rolling. I'll probably have to tell it to change the rotation here, so the lock. No, I can't lock that. This should lock there. That should be rolling with that. Okay, well if we turn angular dampening up to like a high number like 10, maybe have to be higher than that. Linear dampening, we don't want it too high at all. Still want it to slide. You get sort of that movement. Doesn't have these pots in a way. Yeah. Let's get rid of the pots. Oh, I'll just move it. Maybe. What's going on there? I don't get why it's rotating, rolling about. Why is it doing that? It should be locked. I've got a feeling like these will. Got a feeling that these are not doing what I want them to do. Yeah. So that's annoying. Okay, so the modes, constraint modes here are broken in the sense that if you turn on the XZ plane, that also enables a rotation in the XZ plane, which is not what you want. So we need to turn on the constraints to lock position and lock rotation separately. Now, I don't know if they're available in here. Lock, no. Constraint, no. Or if I go to custom plane, let's do normal plane, I'll give it normal. Where is the custom plane then? Custom plane. No idea. Where's that? Oh, right, I could do it like that. Locked axis mode is selected. Will lock rotation to specific axis. Lock axis. Yeah, can't do anything there. Plain normal. Can't set that there. Try yelling at it. Sometimes that I do. How can I set this not here? Okay, let's do plain. No, it's not going to come up, is it? Plain constraint, that's movement component, that's not to do with that. Just movement stuff, and that ain't got movement stuff, it's physics, so that's not normal. Weird, the input looks like the RGB outputs. What? Yeah, I'm gonna see if I'm missing something. Let's quickly Google it. Physics constrained plain normal custom. Yeah, that's just physics. That's not physics. That's just the movement component. Oh, right, okay, so there's a workaround to do it with this. So rather than do this, you add a physics constraint component. Component name 1 is going to be our cube. Component name 2 you leave blank, it'll constraint to the world then. And then we need to, what do we need to do? Look for the particular access set to give plane. Okay. So, alright, okay, so we've got linear limits. So if I set oh, hello. Set the physics constraint here. Linear limits. Okay, we can make this work. So on the physics constraint, we can constrain physics to other, usually use it to constrain physics to other actors. So in there, ooh, I lost my mouse. There it is. Let's go with that. Usually you use it to constrain other actors physics wise. So like a rope, for example, is using this. But we're going to use it to just constrain it normally to the world. But here we can set linear limits. There's a setting on here where you can set the constraint on the linear limits of its movement, and also angular limits, which is rotation. So I don't want it to swing or move or lock in. I want to lock it in all rotations. So I'm going to lock all these. But the linear limits, we're going to lock the Z motion here, And X and Y, we're going to make 3 based on which true or false this is. So I'm going to set limit in the X to 3. And I guess we have to turn everyone off. So set limit in the Y to locked. And then you do the opposite down here. And then we're going to change this one to locked and this one to free. God. Physics engines. It's locking its position. So it's constrained it to its root. That's why it snaps back to it. If I move it like that, that's working that way. Not that way. Oh, there you go. It does work. Sometimes. Bloody thing. What are you saying, Project Storm? Tolerance needs to be tweaked. I think it was working, but it switched quickly between constraints. Oh, what the? Hang on, I'll get what you're trying to do. Ooh. So if I change that, leave that default for now. You go set constraint mode. XZ constraint mode to YZ. What else do you suggest trying? So was it tolerance? Put that there. Compile. Tolerance in what? Yes, it still rotates it. It's because these are just locking the only locking the movement, not rotation. We want the rotation to remain locked. It may be easier without physics. If it doesn't work with physics, we'll try it with without. Let's just make it actually bigger as well. Ooh. Oh, it's not high enough, that's why. Oops. No, we have to move it. There. That works. But when it stops moving, it sort of snaps. Yeah, we'll do it without physics. Let's try it without physics. So for that, we're going to turn off physics. Push. And just disconnect all this. Oh, one key. There you go. Take all this. Move this up. Okay, so we're still using a dot product like normal. So if it's equal to 1, it's going to the X. If it's equal to 0, it's going to the right. So in here, we want to take the... we want to go and... overlap box and do... get player character. No. What do I want to do here? What do I do? What do I do? Brain fart. Alright, so you get the move forward node. Information for move forward here. So that means we're pushing forwards there. So this determines whether I'm pushing forward or not. And if I am, then I want to move this forward as well. I'll turn off the physics constraint. So we're going to do add relative location to the cube. And if it's true, this would be the X. So if it's true, on move. I'm going to take this, multiply this by a vector. Vector times float. And that'll go in there. And in the X here, we'll put in the speed we need to move at. So, speed of the player is 600, I think. We'll change that to like 500 for now. Compile. And let's see if that works before the other side. No. It's actually coming through here though. Let's have a look. Print string. Zero, 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 zero. The only way that would be 0, 0, 0 is if this thing. Oh, if it's not disabled, I need to enable act. I need to enable input. Enable input. There we go. Right. Play. And now I can no longer move up and down. What retro remake game did you make last year? I made Super Smash TV. I don't know what retro style hills they are. I didn't make the thumbnail. I had someone else make it for me. On the print string, move forward. Yeah, 0. The reason why I think it's 0 is because I can enable input on this thing. but I think it is. I think it's because it's not a pawn, it won't work with inputs. If I make this a pawn. That makes no sense because it should still work. Oh, it's because I'm doing this on a move, not on the. I need to do it on like a tick. Sorry, my bad. This is only happening on when I enter it. I don't want to do that. Oh, that was what was going wrong before. I was adding. Right. Okay. So, God's sake. Begin overlap. Do this. And this will be. It has to be on a tick. But in the tick, we'll do. We want this part as well. And if that's true, we're going to there. And I want to do that if get player character. I wanted to do this if the player character is inside this box here. So box overlapping is overlapping actor. Move all this down, put a branch in, plug that in, plug that in, plug that in. It means we don't actually need this. No, we still need an enable input, that's fine. Okay. File save. Oh, I thought that would really work then. I don't know why it's still pointing out 0 for the move forward. Got enable input. We'll drag this down here just in case it goes a bit funky. Don't know. Why won't that work? Change it back to actor. I told you not to consume input because before it was stopping me from moving. But that should still read something. Oh, get player controller. Enable input. Right, try again. There we go. Right. So, on the tick here, we'll add relative location. We don't want 500. We want it. Let's just do 1 for now. And you get that. Cool. Oh, yeah, because inside that's grid box still, aren't I? So we'll fix that soon. Otherwise I can put it from the side here. Right, let's increase the speed a little bit. Let's do that up to like 5. Okay. So on here, we'll do this one in the Y thinner, and the X thinner. There we are. So recap what's going on there. So we only got it for one direction so far. We'll do it for the same for the next direction. Let's go to this old stuff. So when I walk over the overlap for the box, we'll rename this one as well, box X. When I overlap box X, it's going to enable input on it, so I can mess with it. So it just checks it with the player character, makes it input enabled. Then on the tick event, I'm looking at the box X event and see whether or not it's overlapping the player character. If it is overlapping the player character, I'm then looking at the dot product of it's a forward vector. So if I want to make sure that they're going the right direction. In which case, we're dragging this out. In fact, what would be better is I can put this afterwards, so I'll fix it when I do the next part. Anyway, once it does this, it can then add relative location. Now, when it adds relative location, what it's doing is adding an extra coordinate onto its existing coordinate. So that's what that means. And we're adding the get move forward input, which is pretty much 0 or 1, or in between that. Multiplying it by 5 in the X, and then plugging it into there. And that's it. Okay, so let's now make this work for the other direction. So in here, we're going to make this part of a select node. So I'm going to do that, and go into there, put that into a select vector. Now select vector, what that does, it means when it's true, it will choose A, when it's false, it will choose B. So plug that into there. It's A, I want 5 to go in the X. It's B, I want to go 5 in the Y. Compile, save. Okay. Then I want to add another box for the other direction as well. So let's duplicate that. This will be box Y. And I'm going to switch that around. So that's this one here is 70, let's say, and 40. This one is going to be 40 and 70. In the event graph, we take the box X is overlapping actor there, and we want to get box Y do the same thing. And this will be true for either of these, so do OR. In fact, we should do XOR, just to make sure we don't get any weird issues. So XOR means exclusively, so it can be one or the other, it can't be both. It goes into there, that'll choose one of those, I'll go there, cool. Let's, next thing we need to do is enable input on overlap of box Y. So on here, add event, begin overlap. And that'll go up here. And this is exactly the same code, so just copy, paste that. Plug that in, and we're good to go. So now I should be able to push this left, right, and up and down. So up, no. What's going on? is that XOR going on. Print string. Why is it only doing it once? I should do a box standard or see if that's causing issues. It was the XOR that was making issues. But still got the issue of the side here being broken. Okay, I need to fix that. We'll fix this and that'll be the end of this episode, I think. Okay, so the problem is that we don't want to use this method because that's causing that sideways issue. I think we have to just do it bulk standard, one at a time. Check. So we'll do that there. We'll do a sequence. Then goes into there. This we actually don't need to do the dot product in this case now. That'd be 5, and we'll just copy this and put that in there. And change that to 0.5 and change this to be box Y. Okay, hit save, test that out. Oh, and there. Oh, hang about. By any chance? No, that should be moving with it. I think the player maybe just be clipping into both of them. In which case, we'll make them a bit thinner. Do 20. Do 20. Yeah, there you go. Oh, I have to turn that negative. Yeah. So Y here be -5. So up works fine. No, I'm still getting an issue. Why would it do that? So many bugs. I just want to sort that little pullback that happens. That's annoying. What's going on? Hmm. Turn it out. Does it still work just with one direction? Apart from that little pullback thing that happens. Now we will need to do dot products, won't we? I fear we're gonna run out of time to do this. Okay, let's go back to the drawing board a little bit. Right. So, when I enter the, let's just worry about X for now. So on the event tick, we've re-enabled input on it. So we want to see if the only want to do this. We want to get the player's character, get the actor forward vector, get the forward vector of this, and dot product those. Okay, so to print string this, demonstrate and see where this goes. So 1, we're both facing the same way of going north. -1, I'm facing south. He's facing up. So we want to use the dot product, I think, as a multiplier in this case. So that's a multiplier. We want to then get. We only want to do this when this is overlapping player character. Okay. If that's the case, I want to move the cube a vector multiplied by a float, and that would be a 5, but I only want to do it in the direction that we're facing and maybe moving. Move forward. Let's see what happens when I multiply these together. Oh, I forgot to turn off consume input. Hang on. Still got a little pullback there. Yeah, and that's not working there. That's because my down is still negative. So I don't really want to do... What do I want to do? I only want it to move down when we are facing the correct direction that we're pushing in. If I turn around and go back the other way, Yeah, I know why it still pulls back. So I still know. I was just trying to figure out how to get around it. Might have to do 4 different collision boxes. May have to, but I don't want to. But even if you've got collision boxes, you've still got the same issue. When you leave it, you're still not pushing against it. My movement velocity direction has to be the same direction as it. If I get player character, get velocity. Get direction. No. Yeah, no, that'll do that. Yeah, from that to be from 0 to that. That'll guess a direction. If I print string that, so I go down, it's -1 there. And equals 1. Okay. Even if you reduce the box size, it's still going to get a little bit of it. So I'm going to take the unit direction here from the velocity, which is the direction the velocity is going in, and I'm going to compare that against the dot product of the actor's forward vector. So rather than using the character's current forward vector, look at the way they're moving rather than the way they're facing, which may be the solution there. And that goes into there. That goes into there. Let's have a look at that. Okay, so the other issue is when I walk away from it, it just pushes it back in the same direction. And that happens as well. Cheers, Felix. I want to do abscess. I think I've got 2 negatives going into each other there. That works there. Move that aside here. Do a branch here. this. Oh yeah, done the, yeah, cool. Absolute makes it a negative value positive and a positive value positive. It just knocks off the negative thing from it. Okay. So as I said, this is outputting. Let's print string this, so we know what values are coming out of this. So there I'm getting 0. That's because the velocity is 0, isn't it? Yeah, that's why. Oh, you son of a bitch. We're trying to make a pushable block in the style of Zelda, so it only go in 4 directions. And I'm half asleep, which isn't helping. We've got it kind of working, but the issue we got is when we walk away from it, it drags it a little bit, which we don't want. I only want to move it when the player's walking towards it, don't I? So how can I work that out? So that's the condition we need to do, is check when the player's walking towards it, not away from it. Right, we're going to have to get the player character first of all. Do I have coffee? No. I have Coca-Cola. And a bed. Wait for me in a moment. So I'm going to get the player character. Get there. No, what do I do? Get rotation. No, get the velocity. We've used forward vector, not popular, not working. The problem with the forward vector is as soon as you walk, it's literally as soon as you walk away from it. You're still not exactly forward vector, like you're still turning around. That's the issue. So I'm going to get the direction the player's walking in from the velocity. So direction, get unit direction, from this to this, that's the direction the player's walking in. Normalizing, have you tried normalizing? Normalizing what? Oh, normalizing the direction against the object. Normalize the direction against the object. Object's what? Direction they're facing. I don't understand what part of that you mean. Not trying to line trace, but line trace would have the same issue. It'd have the same issue. We need to use velocity, I feel like, because we need to only do it when we're moving and when we're moving towards it. So So, what on brain? I'm so asleep. Oh shit. Calculate the angle between the player forward and cube normal and see if it is less than 90 degrees. I think that'll still cause the issue of it pulling it back though. That's the issue. Can you get the normal of the cube face hit by a trace, then see if the player is moving in the same direction as inverse normal? That's a good shout. That's a good shout. We could try that. Yeah. Right. So I'm gonna try and keep it on the cube. So what we're gonna do here is on tick here we'll do a line trace. Right, channel. We'll give that a shot. Get player character. Get location. Get forward vector. Multiply it by 50. That should be enough. Then add that to this. Okay, so we're doing that. And we get the out hit. Break that. And we're getting the normal. And we're checking that against the inverse normal, don't we? Can I just invert this? Inverse. Transform direction. No, not that. Times by -1. I think that's what we have to do, isn't it? And then we take that and we are going to see if that's equal to. Get player character. Get forward vector. Log that in there. And that'll be our condition. That location will be 5. Then we do that with the move forward. Turn off consume input. Let's see what this does. Nope, that's not coming out there. Oh, it's just the. I think this bit is wrong. Print string. I'm just getting 0. Why am I getting 0? Let's turn on the debug. Not I can see it. What duration? Maybe 50 is just too short. Let's change that to 100. Nope. What? Why is it not hitting that? Yeah, so to block it. Turn value at that. Why is that false? Oh, 1K. Why the hell is that going through that? Visibility. Oh, it's ignoring itself. Idiot. Because I'm casting on the wrong thing. There we go. Right, if I walk away now. Hey! Yay! So well done, sorry. Sorry if I can't pronounce your name right. But we got that working. It doesn't do the drag back either, which is good. Cool. Okay, so we'll turn off the debug. And this. And this. Okay, so that's one direction. This should actually work for all directions now. We don't have to do the separate boxes. We could, in theory, I think, do all at the same time. So if I change that to 70 as well here. And leave that as is. I think it would work no matter what. Oh no, it won't, because we have to change the direction we want to go in. That's fine, we can change that. Compile. Right, so we've got that. Okay, so for this one, we need to do a sequence. Doing that check first. Then doing all again. Pretty much. Down here. And we're going to turn off this box to the other box. And I want to get the... That's fine. That's fine. Change that from that. I think it has to be -5. This one I think we found, didn't we? Oh, but not move forward. I want to get the move right. So that works. Oh wait. Just 5. Now, obviously, because it's not a physics object, you can just push it through the wall. So we need to tweak that later on. That's what I'm doing that. In which case, we could probably turn on physics and then just constrain it and everything. Because we're going to change its location, we're not actually physically moving it. Oh, we are. Shit. Nope, okay. In that case, we have to do line traces out to check if we've got colliding with anything. Or no, this is set to block everything, isn't it? We have to do sweep. Not sweep. No. Right. I guess you just need to do a check to see if you can actually go 5 ahead. So if I do a simple trace out. Line trace by channel. And put that into a branch for the boolean there. So it only does this when this is false. It doesn't hit anything. So the start position will be the actor location here. The direction we're going to go in as well is going to be this. So we'll copy this, paste this here. It'll be this plus vector. And we also have to multiply it by or add the size of the box as well. So it's 200. Add do move right here, multiplied by 200. I think. Right, so that still works like that. I got stuck there for some reason. Can't go any further that way. Why can't I go further that way? Why is it okay to that point? Draw debug for duration. Oh right, it's well too long. That's why. Don't need that 200 then. Yeah, I think it needs to add some length to it though. Yeah, it's 100. Or 50. That'd be alright, because then it gives you a bit of space to go around and push it back, I guess. And go that way. There you go. Done. So we're doing a little line trace out before we push it to see if there's actually space to push it to. So we're just going to duplicate what we've got here. And put that above here. Goes into there. Force goes into here. This one will be 5, 0. And this will be the move forward. So we have here, copy that, paste this. Save. So now we can push this one up to the top. Cool. Done. So we just need to make that thing hit a switch. So what you can do for that is we've got this switch here being called in a level blueprint, and this thing is told to on here. We've got switch press, the floor switch here. Now what I want to do with this, I could, if I rather than do it with the floor switch, I can turn that off. We get the switch reference, which I've got selected already. Create reference, and actually no, we want to do it for overlap, don't we? Add event collision act begin overlap. If the other actor is equal to a I don't know why I clicked on the browser. Reference to pushable block. Put that in there. Do that. And if that's the case, now tell the door to be unlocked. For example. Okay, hit play. So at the moment, I should be able to go through this door. Okay, so I have to push this block onto that switch. I play a sound effect, blah blah blah, and you can go in and take you to the next room. Cool. Okay, so there we go. Yeah, and we can probably go one step further and make it so when it goes ends overlap, we can then check against the push block and then lock the door back up again. But we'll leave it there. It's late. I've gone far much longer than I hoped to do. So thank you everyone for joining me tonight for our live stream. Yep, this is the new space. Welcome to it. Hopefully you get new loads more videos in this space out for you guys soon. So yeah, thank you very much. As a reminder, patrons will have access to this archive straight after the show, as well as the project files that you see here as well. They get every single project file after each episode. Everyone else will get this episode archived on YouTube 2 weeks later. So in 2 weeks time you'll get this coming out. Loads more content coming out each day of this week. More stuff with the Stealth AI stuff. That's wrapping up now on Patreon. The last couple of episodes on that, just done the execution stuff. So that's pretty much done. We've got the puzzle game series counting over on Patreon as well. We've got, what else we got? There's more stuff coming out as well, of little ones and so forth. So yeah, thanks again everyone. I'm off to go get some sleep. Have a good evening, and I'll see you all next time. Don't forget, question time on Wednesday. So bring along the questions. We can answer as many questions as we can in that show. Thanks everyone. Have a good one. Bye.